Our today's lesson is graphing quadratic functions. Now keep in mind there are several ways to graph a quadratic function. Here are some things you can do to get started. 1. Find the axis of symmetry and the vertex point. 2. Find the x-intercepts, if possible. Sometimes it could be fractions, but if they're whole numbers, find them. And 3, count the distance from the axis of symmetry to plot the opposite points. For example, let's say we want to graph f of x equals x squared plus 4x plus 3. First thing I would do is get the axis of symmetry. And we know that x has to equal negative b over 2a. That tells us the line of symmetry, and it also helps us find the vertex point. So let's see where the graph is, the center of the graph is at. So we know b is the coefficient of the linear term, so b has to be 4. So I'm going to put x equals negative, that's part of the formula, and I'll put 4 here, times 2, and a is the coefficient of the quadratic term, which is 1 in this case. So this tells us that x has to equal negative 2, because 2 divides into 4 2 times, and the negative's there. So you have x equals negative 2. This is important. We're going to graph that vertical line, x equals negative 2, to find out the axis of symmetry. And if you want to find out the the lowest point on this graph, first of all, this is x squared. It's positive, so I know it's going to be shaped like a smiley face. And if you want to know where this bottom point is, we're going to find out, we're going to evaluate x equals negative 2 into this expression. So look, if I put f of negative 2, that's going to be negative 2 squared plus 4 times negative 2 plus 3. And then just use order of operations. This is going to be 4 plus negative 8 plus 3. 4 plus negative 8 is negative 4 plus 3, and this gives us negative 1. So this tells us this bottom point here has to be negative 2, negative 1. All right, so let's look at that and see where that puts us on the graph. We're going to plot, we're going to draw this axis of symmetry first, x equals negative 2, and then we're going to plot negative 2, negative 1. All right, for the graph, let's first find the axis of symmetry. That's the line that divides this graph in half. So we know that x equals negative 2. That's the vertical line, x equals negative 2. So we're going to graph that. You count over to the left 2, and you make a line. So we're talking about this. That's our axis of symmetry. And the point, vertex point, the lowest point on this graph is negative 2, negative 1. So if I go to the left 2 and go down 1, that's my lowest point. And you want to pick points to the left and right of the axis of symmetry. So what I do is I just start on the right side and I just count over the distance, equal distance for the left side. So this is negative 2. To the right of that is negative 1. So let's evaluate. When you have f of negative 1, that's going to be negative 1 squared plus 4 times negative 1 plus 3. So you know negative 1 squared is 1, and then you have plus negative 4 plus 3. So 1 plus negative 4 is negative 3, and negative 3 plus negative 3 is 0. So we know that when x is -1, y is 0. So if I go -1 here, I got to go up to 0. Now the thing about this axis of symmetry is that I can count over the exact same distance. For example, if I plug in x is -3, I know this has to be 0 as well because of the property of a parabola, because they're equal distance from the line of symmetry. So I automatically know that. And any points that lie on the x axes are solutions to the equation. But let's graph some more. Let's do one more. To the left, to the right of -1 is 0. So if I plug in 0 for f of x, I get 0 squared plus 4 times 0 plus 3. Well, you know, 0 times 0 is 0, and 4 times 0 is 0. So I'm just left with 3. So when x is 0, I get y is 3. So I come here, I go up 1, 2, 3. Which means when I have -4, I go up 1, 2, 3 when x is -4. And what you do is you just draw this U-shaped curve. And that's the parabola. It keeps going in those directions. Okay, graph f of x equals x squared plus 2x minus 3. We're going to do the same thing. We're going to find the axis of symmetry, and then we're going to find the vertex point, and then pick points to the left and right of the line of symmetry. So x equals -b, well, b is 2, over 2a, and a is 1. That tells us that x equals -1. So the axis of symmetry is -1. If you want to find the vertex point, we're going to evaluate -1 back into this equation. So f of -1 is -1 squared plus 2 times -1 minus 3. So this is 1 plus -2 minus 3, which gives us -1 minus 3. This gives us -4. So -1, -4 is the lowest point on this parabola. So let's start by graphing this. All right, so x equals -1. We're going to go to the left 1, and we're going to graph that line. That'll be right here. That's our axis of symmetry. And our vertex point is -1, -4. All right, so when x is 1, you're going to go down 1, 2, 3, 4. Be this point here. That's the lowest point of that parabola. Now to the right of -1 is 0. So if I plug in 0, I'm going to wind up with -3 when I evaluate into my expression. So I just go up 1. But if it's -2, it's also going to be 0 because it's an equal distance from the axis of symmetry. All right, and then let's say I plug in 1. If I plug in 1 and evaluate that, I'm going to wind up with 0, which is right here. Which means if I plug in -3, I also get 0. And so on. And that's how your parabola is going to look like. All right, what about quadratic equations that have a coefficient, a leading coefficient greater than 1. This one has a leading coefficient of -3. You're going to do it the same way though. So I'm going to find the axis of symmetry. X equals negative, and b in this case is 6. 2 times a. A is -3. My leading coefficient is -3. So this tells me that x must equal, well, 2 times 3 is 6. In this case, it would be -6. -6 divided into -6 one time. So x has to be 1. And another thing I noticed, since this is negative, I know my graph is going to go down like this, or have a frown to it, as some say. So if I want to find this top point, I can evaluate x equals 1 into this expression. So f of 1, let's say -3 times 1 squared times 6 times 1 plus 1. So I get -3 plus 6 plus 1. This is 3 plus 1, that's 4. So f of 1 has to be 4. That tells us that the vertex point is 1, 4, or my maximum point. And you're going to do the same thing in order to figure out the graph. So let's go and plot 1, 4. Yeah, but first let's plot the axis of symmetry, x equals 1. So x equals 1, that's going to be to the right. It's going to be this right here. All right, and then the vertex point is 1, 4. So I'm going to go over 1, up 1, 2, 3, 4. Okay. And now I want to evaluate. So let's say to the right of this is 2. But I'll probably pick a smaller number though. To the left of this is 0. So let's plug in 0. So -3, 0 squared, plus 6 times 0 plus 1. Well, 0 times anything is 0, so we're left with 1. So when x is 0, f of 0 has to be 1. So, which means if I plug in 2, this also has to be 1. That's how that works. And it's going to go downhill this way. All right, graph f of x equals 1/2 x squared minus 4x plus 5. Okay, same thing. We're going to get the axis of symmetry. So x equals negative b. But now be careful, b is -4, so I put -4 here, but this minus is part of the formula. And then 2 times a. A happens to be 1/2, so I'll put 1/2 here. And just simplify that. Negative and negative is positive, so it's going to be positive 4. 2 times 1/2 is 1. So this means that x equals 4. That is my line of symmetry. If I want to find that vertex point, and by the way, since this is positive, we know the graph's going to go like this. So you want to find that bottom point. What we're going to do is evaluate x equals 4. So I get 1/2, 4 squared, minus 4 times 4, plus 5. 4 squared is 16. And 4 times 4 is 16, plus 5. take half of 16, that's going to be 8. 8 minus 16 plus 5. 8 minus 16 is negative 8. And negative 8 plus 5 gives us negative 3. So we're going to have 4, negative 3. That's going to be our vertex point. But x equals 4 is our line of symmetry. So let's see what that looks like. Let's graph this. We know that a vertex point is 4, negative 3, but the axis of symmetry is x equals 4. So x equals 4, that's going to be over here. You got to count over to the right 4. Just 1, 2, 3, 4, and make a line, vertical line. All right, and we know that the vertex point is 4, negative 3. So I count over 4, I count down 1, 2, 3. It's the lowest point on this graph. And you want to pick points to the left and right. It's easier if you pick the smaller points, because you can pick the other points by counting over the same distance from the line of symmetry. So for example, I'm not going to pick an odd number. This is 4, that's 3 here. I'm going to pick 2 because I have a 1/2 as a coefficient. So f of 2 is going to be 1/2 times 2 squared minus 4 times 2 plus 5. All right, so when you square that, that's going to be 1/2 times 4 minus 8 plus 5. And half of 4 is 2. So 2 minus 8 plus 5. That's going to give me negative 6 plus 5, which gives me negative 1. So when f of 2, when y is 2, when x is 2, y has to be negative 1. So I'm going to go 2 over 2, go down 1. But now the line of symmetry says this. Look at this. I count over 1, 2 squares from the line of symmetry. So if I go to the line of symmetry and count over 1, 2, I can make a point right here. Which means that when x is 6, I also get negative 1. I'm going to do the same thing, but I'm going to pick an even number. I'm not going to pick 1 because I have a coefficient of 1/2. So let's try 0. If I plug in 0 for x, remember anything times x is 0, so all you're left with is 5. So when x is 0, y has to be 5. So I'm going to count up 1, 2, 3, 4, 5. And I can count the same distance back over. I got 1, 2, 3, 4 squares to the line of symmetry, so I can count out 1, 2, 3, 4 and complete this graph. And it's going to go like this. This concludes our lesson for today.